So yeah, I don't know. The failures idea, I was just kind of like thinking about
This is a great idea.
like experiments that I've done that didn't work out, and why did I do them? Why did I think they were a good idea? What did I learn from them? How, and also like how has that changed my decision making in the future? Because I feel like every failed experiment has kind of like led to maybe like a deeper level of skepticism
Yeah.
at some point about what's the easiest way to do this? Like, how should I act given the resources I have?
Definitely.
Because a lot of the failures came from me just assuming I had infinite resources, infinite time to go and solve
This
the
is
problem.
like when you started spinning up SimCLR.
Yes, that's exactly. This is exactly. But also, in my defense, it's also like when you span up that convolutional autoencoder. Remember that?
100%.
You know, that's what I was thinking about. It's just like these things were, except your experiment cost $5.
Yeah. Yours cost
Mine,
50,000.
40,000.
Yeah,
So,
just a couple orders
yeah.
of magnitude between us, but we'll count them both failures.
Yeah. But it again, in my defense, like I said in episode 1, we had the credits to spend, and
There's
we didn't know
no
how to spend
defense. You fucked up. That's it.
In my defense, we had to spend the credits. They were going to expire. Actually, we had 2 months to spend $40,000 in credits.
Whatever
on
helps you sleep at night,
Google
dude.
Cloud. It definitely helps me sleep at night.
When you mentioned failures to me, I thought it was a good idea. But then as I was like thinking about it, I thought less about the individual failures that I've had, which have been countless and innumerable, but more about like the classes of failure types.
Yep.
If that makes sense.
Yep.
Like one of them, I feel like that's a huge theme, is that I feel like I've failed over and over again in achieving true generalization.
Oh, interesting.
Yeah, like I worked on global land cover and we theoretically generalized, but I think it's kind of a cop out in the sense that the taxonomy that you define for global land cover almost bakes the generalization in for you. It's not that the model didn't work over various geographies. It's just that it's not solving an extremely hard problem over a lot of these geographies, if that makes sense. But harder problems, I feel like I haven't gotten them to actually generalize well. I don't know. I'm curious if you've run into that.
Well, what do you mean? Like, so are you talking about like geographic generalization?
Yes, geographic generalization.
Well, I think we kind of spoke about this in that, is that ever really a hard requirement? Like, I feel like most of the time you get away without it, right? Like you post-process a little differently in this region and that region, and that's just the way the cookie crumbles. No?
I think a little bit, but let's just forget machine learning for a second. But like, just
Okay.
take like some NDVI, like this is a forest, this is not a forest problem, and you're solving it with NDVI. The thresholds and the time of year at which you have to cut that doesn't work in the same place everywhere. And so I'm not sure I fully agree with you when you're just like, oh yeah, you just post-process it, you just tweak this thing and that. I think it's more that the approach itself, as you start to be like, oh, this is going to work over South America as well as Russia, it just, like the onion keeps like unraveling and it becomes more and more complicated. And usually at some point I say, oh, it's almost like a different problem. And I feel like I've run into that with both the machine learning methods, but then across varieties of classes of problems. So I think it's more than just post-process, tweak a different knob and call it good.
Right. I guess to me it feels like the way to solve that requires so much more data and so much more care in designing the data set than like the pass to the first map where you realize it's a problem.
Yeah.
And it almost feels like at that point I don't know. It doesn't feel like it's feasible to go back and like I'm going to retrain and try and
Yeah,
hammer this
totally.
model into it so that it can predict it everywhere. And I guess like the statement about the post processing when it's different is like it's if the thresholds are different, then it means like the physical signal is just different in these places. And do we really want? I've never felt the pressure to be like, except in actually, interestingly, an academic setting, I've never felt the pressure to be like, okay, this has to work the same way in across all regions,
Yeah.
because I don't know, that hasn't felt like a very, maybe it doesn't feel interesting, right? Like we
Yeah.
know that there's physical differences, and the physical signal is what drives the model, and so it in some ways, I guess it's reassuring. I don't know. I guess in the case of land cover, where it's like you want to deploy a global land cover map and it has to fit into everything, it has to cover the world so that you can provide it to people.
But let's say it's a simpler problem. Like, let's say you're mapping residential solar across the United States, or mapping oil and gas well pads across, let's pick the US again. And that's just like these are simpler problems, right, than like land cover, in the sense that it's like you just want to find one thing. I think even in problems that simple, what I've found is that you try to take one model that works, oil and gas detector works well over West Texas, Southeast New Mexico, and then you go deploy it in Pennsylvania and you have all
Right.
kinds of problems. And then, I like went through this, and then you go and label in Pennsylvania. And then what I always find is I hit this ceiling of this trade-off, this trade-off barrier that I can't cross, where it's, oh, I gained some sensitivity in Pennsylvania, and then I lose some sensitivity that I had in some
Like
other
whack-a-mole.
places. Yeah,
Yeah.
exactly.
Yeah.
It's like this whack-a-mole
Yeah.
thing. And then at some point I say, what's the point in having, I
Yeah.
sort of like give up on the one model approach. And then it's like you start doing these regional models, and then you're almost like devolving back to this space that nobody wants to talk about anymore, because everything's all about, just embeddings, do it. And you know what I mean? It's just like, oh yeah, it's just one shot and like, oh, it's solved, done.
And it's the same everywhere.
Yeah,
And it's fine.
yeah.
Yeah, I think that's interesting. It's like we like in our heads, the well pads are the same thing in Pennsylvania and in the
Totally.
Permian Basin. But in the imagery, they're totally not. Like the background is totally different.
Yeah.
And that it would actually kind of make sense to me that you hit a ceiling. Like I was just thinking that like at some point it does make sense if you are chasing performance, right? Like if you want the model to be as good as it can be, then yeah, it makes sense maybe to have two models, or maybe you just need a much bigger model that can handle all of the extra data. Like have you ever tried like scaling up as you're scaling up more data, more diverse data?
Well, I actually have a question for you based on that. So if we think about, so there's linear models and there's nonlinear models, right? So if we take nonlinear models, neural nets are good nonlinear models. And I guess where I feel like I get stuck almost all the time is I feel like it's hard to prove, but I feel like I'm stuck in a local minimum, but I haven't hit the global minimum, I guess, in this like convex optimization problem. And I guess what you're saying with the bigger model thing is like, can I get lower so that I can solve these cases in a single shot, because like that's where the true decision surface is? Is that kind of what you're asking with the like scaling up thing?
Yeah, but I guess also what I'm saying is that I don't know if it's worth it to try and do that. Like that, I don't know if it's I don't know if it's easy to do that. Like if it's just a matter of like you give your model more capacity so it's able to. Like,
So in the neural net
blast-
case, this is just like more weights.
Yeah, like more deeper, more layers. I guess.
Yeah, deeper.
deeper, and because you're shoving more data in, right?
Right,
so
right,
like
right,
you can
right,
make
right.
the argument You can make the argument that like, okay, maybe it's a capacity problem.
Sure. Even though these things have, insane numbers of parameters.
Yes, already insane. But and also like this is the other thing is like the Wellpad problem. I mean, the Wellpads are they're not that diverse, right? Like the
No.
backgrounds are diverse and the acquisitions are diverse, but like we're not talking about like Malamute versus Husky, which is like my favorite example of that, right? Like that's you're not asking it to tell the difference between a particular kind of Wellpad and a
No.
particular other kind of Wellpad that.
But
So-
I mean, as you get into the Wellpad problem, there's places that are being fracked, and there's well pads that are unused, and then there's like there is a little bit of nuance in it. But you're right, it's not the Malamute Husky problem.
Right. I just always think about this as. So actually, this brings me this one. When we said we were going to talk about failures, one of the things I also thought about was that at some point I also tried to reproduce an existing coconut palm map, which is different to oil palm. Decal as well had the same people who had published a global oil palm map also published a global coconut palm map.
Okay.
And in the paper they had made the argument that I think it's the B11 band. Is that SWIR 1 instead of 2?
Yes, it's SWIR 1. Mm-hmm.
There's a difference between oil palm, which is like the nearest confuser, and coconut palm, or there's enough separation that you can make the argument for a global coconut map as a result of this. And they made the map. I looked at it. The map looked decent, And one of my failures was not reading the paper carefully enough in this case. So it is important to keep that in mind. And so I did not care about the global problem. I just wanted to demonstrate that this was possible at a small scale. So I took an area in Indonesia that I was already familiar with, and I sampled the map. I sampled the coconut map and some oil palm and some other negatives and and in the paper, I think they didn't use like any fancy architecture or anything like that. It was like a UNet.
Yeah.
And I trained the UNet and I was like, this is for sure going to work because it's like a smaller area and supposedly the signal, and I'm feeding in the Sentinel-1 bands and the B11 band that helps distinguish between oil palm and coconut. And I'm like, this is for sure going to work. Like they made this map, they made a global map.
Yeah.
I'm training a network on a smaller area. I'm kind of like trying to overfit to some Indonesian island just so I can do like a proof of concept demo kind of thing. And it never worked. Like the oil palm, there was just a ton of oil palm false positives, always. Like I couldn't get it. And it was a bit like the whack-a-mole problem you were describing. I was like, okay, well, maybe I just need to feed it in more oil palm examples as negatives so that it knows that these are negatives, and then the coconut signal would get worse.
Yeah.
And then I would, and I...
So, I mean, I feel like that feeling is like you just feel like you're going along that little piece of the local minimum and you're trapped.
Yeah. It's totally trapped. It's a horrible feeling. I feel like I'm better at recognizing it now. But at the time, I obviously, I went back, I checked that like everything was working and the data was the same and, visualized every tile and really made sure it was working. And then after a week of just trying this and just playing whack-a-mole, I went back to the paper and there's like a tiny, in my defense, there's 2 sentences in the paper where they say, oh, and by the way, there were still false positives that we manually removed from this map. And I was just like, I had that feeling already that it wasn't working, like I already had that feeling, but I just felt like I was going crazy. Like this should work. They produce a global map, B11 band, like this should be different. And, and in the end, the easiest thing for me to do was just to like deploy the coconut model, which did detect some coconut, or things that look like coconut, and then use an oil palm map to do post-processing.
It's always post-process.
Right. And so that's why when you asked me about generalization and things like that was my immediate reaction, because I think it's possible to
But
train
this
a
is
model.
different from generalization. This is like this is just like you were talking about detection in a local area, right?
Yes, but the question is like, is there signal? Is there sufficient signal in the data?
So maybe it's more that this problem is just kind of underdetermined with the
Right,
data that
right.
you have. One underdetermined failure for me, one thing that comes to mind is like I worked on oil slick detection for a while with SkyTruth, and so SkyTruth has this platform, Cerulean. They have oil detections detected from Sentinel-1 on this like awesome free and open platform. I worked on some early
Shout out
version.
to Jason.
Jason, yeah, who's awesome. I worked on an early version of this model, and I don't know how different it is now, so I can't really speak to it. But you basically, the problem setup is pretty easy. It's you have Sentinel-1. These oil slicks appear in the ocean as these like dark, streaks, often near ships who are spilling oil or other oil infrastructure or stuff like that. And you want to identify these slicks, right? You want to segment these slicks, delineate them. And there was pretty good labeled data. It wasn't perfect, but it was solid. And with Sentinel-1, let's pretend that like INSAR and coherence is not a thing. So you're just, and GRD data, right? So it's just VVVH for the most part.
Yeah,
so
backscatter.
That's what you got, amplitude backscatter. And this was a perfect case where it was, train a unit. There's good, again, I think good reasons for doing so. There's like pretty good spatial, like the slicks themselves are like often long and narrow, and they have this like very unique spatial structure, which I think our eyes key on. So, it makes sense that a neural net would, or a CNN would do pretty well at that. And it was the same issue where it was, I feel like there was only so good the model would ever do. And in practice, there's enough confusers in the world, kind of like your oil palm example, where with like natural wakes in the ocean or weather causing dark areas in the ocean or for like 10 other reasons. I don't know enough to know all the reasons why this is happening, but it happens, and they can look like oil slicks and they're not. And you just hit this wall with how well you can do with Sentinel-1. And I just kept having this feeling of it doesn't matter what the model is.
Right.
I'm never going to get past this. And it's such a depressing feeling.
It's the worst. It's so, I don't know. Yeah. So what was the conclusion to that? Like, we link it to like AIS data or something like that, like a ship has to have passed.
we linked slicks to AIS, and we would try to predict. I worked on some of this too, like the trajectory matching problem. So you have the slick that you detect, you have known AIS of ship trajectories, and basically you can try to link the two, right? You have timestamps for everything. It's this basically this like tracking estimation problem. But that's a separate problem from the slick detection. I'm just talking about the slick detection itself, like do the best job ever at finding slicks. And it's just, I think really a lot, like working on stuff like this, you just, it's cool, like how much you can do with the data. And then it's sad with how limiting it ultimately can be for sometimes for like these like real problems, right? That people care about.
Yep. Yeah, I mean, it's devastating because, like people are dependent on you, right? Like they're like, how's the model going? Like, hey, and you're just like, oh, it's great. It's totally fine. And I think there is a part of this, like when you just come to terms with it and you just have to be like, all right, this is the best I can do. And now we need to think about like other ways to post-process this or just another way to hack at this problem. And sometimes like the things it can't solve, like the co-occurring false positives of like weather or something like that, you can filter out via other means. Like you don't have to use the model to do that. And maybe it would be possible for you to for you to use a model to do that, but you would need to collect so much more data,
Yeah.
For it to maybe have a shot at distinguishing between the two, between like the failure case and the real thing.
Yeah.
Yeah, it's not fun. I think I was thinking about this, like how do failures like why do they happen? And I have recently at least been feeling like they've been happening less and less to me. And I think
You're
that's
just getting better at
because
your job or something else?
I'm getting better at problem selection. Like I'm getting
There you
better
go,
at being
setting yourself up for success.
exactly like setting expectations. But also if someone like 5 years ago, if someone asked me like, oh, is this possible using satellite imagery?
Yes.
I would just be like, oh, like maybe I should go and try this and see. And I think I have a better sense of what is or isn't possible, and also like
Right.
how things fail. Like sometimes the model is good and there's signal in the data, but Sentinel-2 isn't near real time enough for it to be relevant, And sometimes it's just like I can't make up more data. Like I can't launch another satellite so that you know exactly when this happens.
Yeah.
I can tell you which week it happened if there's no clouds, and like, is that the kind of thing you're interested in? Because if it's not, I shouldn't even go and try this.
And I think that's an intuition you build up only when you internalize like the three axes of like Earth observation missions, like spectral, spatial, temporal. Like,
Yep.
and like understand the trade-offs between each one. Like, I feel like once you really know like the main sensors and where they fit within those three dimensions, then you can take a new problem and you can immediately map it onto that and be like, oh, we'll be able to do this, won't be able to do that. Yeah, that's cool though.
For sure, like, if someone wants daily or as close to daily as they can with a long historical time frame, then they better hope their problem is like a 250 meter or 500 meter resolution, right?
Which, like, let's be honest, not a lot of problems are.
No, and the opposite is like if your problem's 10 meter resolution, then you're going to have to be not that stringent on the near real time requirement. Right?
Yeah.
And I guess it is exciting that like a lot of new satellites are being launched and all of this stuff.
And I do think Planet has, in some sense, changed the game. They don't have like the historical baseline, but they have, and they don't really have the multispectral part of it figured out yet. Even though I think all that's changing with newer constellations, but in between Planet Scope and SkySat, you can get daily medium to high res looks. I mean, for SkySat, depending on how things are tasked, but with Planet Scope, 3-ish meter, supposedly sometimes. Sometimes. But almost daily. It's you get some real looks.
Yeah, and we're joking around about like, okay, is it spectrally reliable? Do they have the historical baseline? But like just being able to look daily is already,
especially for spatial kind of problems like construction activity or land clearing or so many things that I'm looking at a lot.
You're looking at
it's
not
funny,
a lot of happy things.
It's funny you mentioned the choosing your problems for success. I feel like that's so much of my job is figuring out within the newsroom which problems can actually be solved in any reasonable capacity with satellite imagery, and most problems can't, which like is also depressing because it feels like they should be, but then the uncertainty of so many things like measuring heat from data centers or heat
Right.
from power plants. It's like there's so many other variables that go into it. The atmospherics, the clouds,
Yep. Yep.
getting reliable measurements over time. It's just, it seems so possible, and then you sort of start doing it and you're like, oh, this is definitely not going to work.
Yep. We had a very similar problem at Grow. People were interested in knowing, I think it was like fertilizer plants, when they were active and when they were not. And apparently when they're active, the furnace... yeah, I think it was fertilizer. Or was it aluminium? Anyway, aluminum, as you guys would say.
Aluminium.
That's how it's spelled, okay?
Sure, man,
if we're
whatever.
But basically, these furnaces were supposed to be burning like insanely hot.
Okay.
In the facility, and basically we looked at like any sensor with a thermal band. But already I was a bit like, well, you know, if we have daily acquisitions, if you get one acquisition a day, and it just so happens that it's not on during that part of the day,
what's the chance?
Yeah, and then you add in clouds, and then you add in, you know, and the signal they were interested in was like, when do the plants turn on and off?
Yeah.
It just felt like this is not something we should try and do via satellite imagery. Like, we should become friends with someone who works at one of these plants. You know, like that's probably the fastest and most reliable way to do this thing you want to do. And I think that was...
But those are hard friends to make.
Those are very hard friends to make. Yes, those are hard friends to make. A lot of people are trying to be friends with them.
Yeah, I worked on very similar thing at a company where we were doing this for climate trace. This was early days, but almost the exact same problem. Like, predict whether coal plants are on and off, and then the stretch goal is predict sort of like actual usage of these coal plants, right? Like not just whether they're on or off, but like how much are they producing or not in terms of energy. And even the on and off problem is like, at least when I was there, we didn't solve it. Like, it just didn't work. And, you know, you can look at smoke plumes coming off of smokestacks, but you don't always see a plume everywhere because it depends what the weather conditions are like in that place. Like, if it's really humid or if it's not humid at all, the plume just might not be observable. Thermal data is pretty sketchy for all the reasons you talked about. So basically it becomes a guessing game, and it's just a horrible tool to actually do it reliably.
Yep. Yeah. And I was, you know, it's funny you say like, problem selection is a huge part of your job. I think problem selection should be a huge part of every job, right? Like, you have finite resources, and
yeah, but what if your whole company is built on, we are using satellite imagery to do crop yields for 100 different crops in the world?
Yep, absolutely. Then that's poor problem selection.
Yeah, but if you're just working there, you can't choose the problem. You got to do the thing.
Yeah, no, absolutely. I meant like more like the people starting companies, people investing, people like, you know, and I think if you are working there, it's still maybe part of your job to try and convince people that this isn't possible, and part of your job,
fair enough,
to find what is possible and useful, and kind of do that based on what you know. Which is not like available to everyone or easy. But I think I just see this time and time again where it's someone has an idea, like someone in sales or someone who's maybe doesn't have the right problem selection intuition, and people get excited because usually the things that people get excited about are problems that aren't feasible, and that's why they're exciting, because it's like, wow, what if we did this?
Right, it's a moonshot or something.
Yes, this would be really cool and valuable. And then you end up with, it's almost like cognitive debt, right? Like, instead of technical debt, it's like someone didn't do the thinking, and now you have to do the thinking and go and figure it out. And it's a pretty terrible position to be in.
Yeah.
Because it feels like it's your fault, even though it's not. You know, you're just like doing your best. and I just feel like if we would be better off if there was better problem selection across the
Are
board.
we being too are we being too prescriptive though in like what is possible and what is not? Because I think sometimes the line is a little
Yeah.
you know, it's like with
Yes.
companies that are like
Yep.
trying to do something, it's like it might be on the edge.
Totally. And I think sometimes it's not just your job to maybe like it's your job to figure out if it can be done. And that's a different story. Right? Like it's a different story if someone comes to you and is like, this would be really exciting if we could do it. Like what are the steps you need to take in order to figure that out? To like convince yourself of like this is worth pursuing or not. That feels very different. I think in agile terminology, that's called a spike. That feels very different.
I wouldn't know.
Yeah, I'm deep in agile at the moment, unfortunately for me. But the idea of the spike is like go and figure it out, and let's figure out the experiments we need to run in order to figure out whether this is going to work or not. But I think a lot of the times something's already been sold by the time it gets to you.
What do you mean by that?
Like someone has already promised someone else that it's possible.
Oh, the whole yeah.
You know?
Yeah. Well, that's just venture capital style
Right.
companies,
Right.
especially in
It's
this
sales.
field, or maybe it's
it's
every field, but
I think it's just sales. Like the
Yeah.
incentives are misaligned, right?
Yeah.
But I think it's like definitely worth. I mean, it's an interesting question, right? It's definitely worth trying a lot of things, especially if
Yeah.
the payout's big.
sure.
But at some point, I guess that's how you become like an old curmudgeon, right? Like you've tried so many things, and so many of them have failed that you're just like, this will never work. Well, actually, can you think of something where that in any company you've ever been in, where you're like, this is not going to work, and it did? Like that you were adjacent to, or that you worked on.
It's not gonna work, but it did. You know, I don't think I can think of something.
Right. Right. And I think
That's really sad.
it's really sad. And I think the reason is that like the field is grounded in like physics and science, right? And limited by physics and science.
Sure,
right? Like
sure.
you can only get so many acquisitions with a sensor this big and this kind of aperture and,
Yeah.
and whatever. And so at some point, or I don't know, at some point if you've seen enough things, it becomes I think there are a few anomalies where this doesn't really work out. I feel like actually methane detection in Sentinel-2, maybe to some degree, I would have thought that was less possible than it proved to be.
Cool,
even though
yeah.
I'm not an expert in it.
Yeah.
Like if you looked at the spectral response of Sentinel-2, like where the bands are, and how there's really only signal in like 1 or 2 bands, I think.
Yeah.
And I feel like that problem really leverages that band and then the spatial properties of the plume. I feel like that's something that if you had told me you were trying to do that and I wasn't that educated about the problem, I would have said like, I don't think that's possible, but I guess it's kind of turned out to be. So, something that the sensor's not designed to do
Yeah.
per se, but ended up working out to some degree.
I think it's a good question. I would say my current job is where I feel like I've had some of the most success, but also also a lot of failure. But I think the framing of your question that you had originally asked is a little different, because it's not that. I think there were certain ideas that we were pursuing for a story or an idea that I thought would be very hard to do, and that ended up working out. But I think it was more constrained by the like timeline of news, if that makes sense. So often for something to work out, we have to be able to do it within weeks or less. And so like,
Right.
can we spin up this thing to identify this thing, across this place as part of data for a news story? And it seemed like, there's no labeled data set. There's kind of like not a lot of places to start, but we were able to do something within a certain amount of time. But yeah, that's less about the physics and the feasibility and more about we were just able to do it in time, so it made sense. And so maybe that's more of like enabled by, platforms like Earth Engine and tooling and stuff like that.
Yep. Yeah. I feel like maybe this is also what you said maybe in the first episode about like we're running out of ideas. Like maybe past a certain point, it's just you've seen the deforestation detections, you've seen the oil slick detections, you've seen like all of these different models and how they failed or succeeded. And so a lot of ideas are just being rehashed with like the same sensors and the same, a slightly different spin on it. And so it gets like easier and easier to tell like, well, this didn't work out last time. And so I don't think it's going to work out this time.
Or you're solving the same problems, but with like brand new tools, like embedding fields or insert foundation model or, but it's the same problems. You're just like maybe doing it faster or, maybe generalizing better, neither of which I'm fully convinced by. But but I feel like that's the claim. It's like, what's the actual like new thing that we're doing?
Yeah. And maybe we just shouldn't expect that many new things because like the sensor is the sensor.
Yeah.
And the repeat time is the repeat time.
But those are changing, right? With the new launches? Isn't that the whole...
Yes. I guess that is changing. But even then, you're not going to have like a historical baseline, which is what you typically need for a lot of like analytical products.
Yeah.
I guess you can make the argument that like, like the modus veers transition, like, oh, we can match it or learn one sensor from the other and it might be good enough. Yeah, I mean, I think that is the most exciting thing is the new sensors, right?
Yeah,
like
the new sensors. Yeah, definitely.
Or even a product like harmonized Landsat Sentinel with the addition of Landsat 9, which means you're just getting a lot more acquisitions or something like that. Like, I just feel like those are the things to be excited about because I think those are the things that unblock new applications or new requirements on near real time or whatever.
Sure. Have you ever had a failure turn into a success?
Ooh. That's a good question. Like total? Like basically
no, you can define the terms.
I can't think of anything, and I think the reason for that is that each step of the process kind of gives you some signal about the next step. And I can't remember ever being just surprised by something that wasn't like a bug in my code or the data processing or something like that, where it went from like not working to all of a sudden working. I would have to think about that. What about you?
I'm trying to think. I think maybe some success that I've had has been in reframing the problem or like redefining the requirements, if that makes sense.
Yeah.
So it's like it's like a fake success. It's like you haven't succeeded by gleaning more signal out of some sensor or set of sensors. It's that you have properly reframed expectations to everybody involved so that everybody thinks the thing you're doing is a success.
You're right. I mean, what you're describing is very different to the question you asked me.
I said you could define the terms.
Yeah. I think yes, and I think that's definitely like a huge part of the job, actually, right? Like,
Just bullshitting is one way to say the whole thing.
being persuasive, right?
Yeah.
Like, but in order to be persuasive, the first person you have to convince is yourself.
Yeah,
Right? So
yeah,
like
for
running
sure.
the experiments to convince yourself that like, okay, here's like, maybe we're not going to get the gold medal, but here's a silver, and silver's pretty good, right? Like,
Yeah.
and I think usually that goes back to the person who wanted the thing done, like the stakeholder in the first place, that wasn't able to do it themselves, so therefore they're maybe not as technical, and trying to understand what is the thing they actually wanted and how do they want to use it, and is there like an equivalent thing or something that's close to it that we can produce.
Yeah. My very
feel
poor
like that happens
example
a
of
lot.
this. My very poor example of this is when I was working at Series Imaging. We were doing all kinds of crop-based. We're trying to do more crop-based, NDVI or, crop classification, in-season corn, in-season soy, that kind of thing from satellite-based data. And that was relatively new. I joined kind of late. So the core of the business was really aerial imagery with thermal, doing water stress, doing very hardcore remote sensing on fields that worked super well. Trying to expand the market, trying to incorporate satellite data. And I was working on cover cropping. So like trying to identify where fields were cover cropped, which fields were cover cropped or not. And it seems really easy, right? Like I saw that problem. I was like, oh, NDVI in the off season. Done. Turns out that's definitely not how simple it is. And so, it kind of worked in some places and didn't work at all in other places and really didn't generalize well. And which is why I started talking about generalization in the beginning. I feel like I've been bitten so hard by that. And there weren't these like huge requirements or anything. It was just like, what could we do? And there were a couple other problems I looked at too that I feel like were equally failed. But what I did in the process, how I turned it into a success was in the process, I like built a lot of Earth Engine based tooling to be able to look at look at indices over various fields very quickly. So like click on this field, you can look at NDVI, historical time series, pick your sensor, MODIS, Sentinel, Landsat. This is just like super straightforward Earth Engine code, right? But this kind of interactive tool was like useful and valuable.
Yep.
And so that was demonstrating the utility of satellite data to stakeholders, to people who might be interested in buying those products. And so I failed at every single task I was given, I feel like when I was there, but I built some things that were useful. And I think one could view my tenure there as a success. And, that's about as bullshitty as you can get, but
Right. Well, we can bring James on and ask him about whether your tenure was a
sure.
success. No,
Yes.
that's no, I think that's a great point. It's like even zooming out a little more. It's did I do anything useful on the way to this?
Yeah.
And maybe there's another problem that can be solved with the tooling I built to investigate this problem. Why was the cover cropping so hard? Was it like a timing thing? Like if you had more acquisitions, do you feel
It's
like that
well,
would
in
have
the
solved
Midwest, it's like weather's super brutal in the winter, right? And so it's like trying to tease NDVI out of the background is really hard for like this low cover crop signal. It's not like what people are planting for cover crop, in the
like
Midwest,
clover or
upper
something, right?
Midwest. Yeah, it's like barely noticeable. It's like you got snow, got just the reflectance conditions are very difficult. So it's like, I looked at field over field after field. It's like you get clouds for 3 weeks in a row. It's like God knows whether you're missing this or not.
Right.
With MODIS, it's like forget it. You're not seeing it.
You're not seeing it.
But in Maryland, it's super easy. It's like so obvious, and totally different climate conditions. And there's a lot of cover cropping happening in Maryland because of government incentives and all this and that. And Yeah, it's just, all these problems that seem easy, you start doing them. And I feel like this just happens to me over and over again. Oh, yeah, that's like 3 days.
Yep.
3 months later, it's like you have not solved it.
You've not solved it. Yeah. Yeah, I think maybe a similar case was we were working with some sugarcane traders, and they were obviously really interested in yield and production, but we only had, yeah, I mean, at most you're going to have like 25 years worth of data using Modus, right? So
Sure.
that's very little.
Maybe longer
And
with Landsat, but no revisit.
yeah, and I don't know if the older Landsat would have had enough acquisitions over all the areas you wanted to like calculate good enough NDVI time series.
Sure.
over
That's
the
kind of what I meant
growing
by
season.
revisit.
Yeah.
Like Landsat
Yeah.
5 is not revisiting that much.
Right.
Yeah.
Right. And so when you're doing like an annual yield production modeling problem, so basically the most you'll ever have is 20 to 25. You can fan that out. Like if you split it up into different counties or states, you can multiply that by the number of states, but it's like not a high data density problem.
Right.
In the case of, sugarcane in Brazil, really you're talking about like probably 10, 12 data points. And so, I was doing all of this NDVI time series and you got 10 data points. I mean, really, what can you do, right? Like restrict the number of features, try not to overfit, really do a lot of praying, but in the process, when I was looking at the NDVI time series, instead of just looking at a year, I would look at them longer. And I noticed that over some sugarcane fields, there was like a drop in some years. Like there was just, basically the sugarcane is ratooned. I think that's what the process is called. So when it's fresh sugarcane, it grows to a certain height and gives a certain yield. And then every year following that, it's cut down, but it's not uprooted. So it grows back from the same roots. And the yield drops a little, but the farmer can continue processing it that way. After the common sort of farming practice, at least in Brazil or in these areas of Brazil, was that after 7 years, you uproot everything, cut everything down, burn everything down, and give your field like an off year, or plant maybe soybean or something like that. And so in looking at the NDVI time series, another very important thing is that if you irrigate your field, as in you don't just rely on rainfall, you don't need to do this process. Like the yield stays somewhat constant.
I see. Cool.
And so basically by looking at the NDVI time series, which, I was looking at them over a course of like 10 years or something like that anyway, to do this yield modeling problem, I realized that you could tell the difference between irrigated and non-irrigated sugarcane fields by looking...
The regularity of it.
Yeah, by going back in time and basically, has this field ever had like an off season or a non-sugarcane season?
Nice.
And if it has, it's highly likely to be...
That's what the traders want right there.
So that wasn't exactly what they wanted, but now you have some extra signal about like, the percentage of sugarcane that is irrigated in a certain county or area or equivalent. So again, that's another case of like, I'm still not that confident in this production number I'm producing or the yield number I'm producing, but hey, here's an extra piece of information that you didn't even know was maybe possible to detect.
Just adding value.
Imagery. Right. Shareholder value. I mean, that's the name of the game.
Yes.
And so maybe that was like a case where, like you kind of set up to fail in some ways if you're trying to predict yield from 10 data points, but you can like try and turn it around by being like, okay, well, here's another piece of information you might be able to use.
Here is possibly a controversial take on some of this, which is, I think the common thread between the last two examples we talked about is that building the tooling to be able to look at the data in the way you want to look at it is fairly easy. Or it might not be easy, but it's clear what you want to
Yep.
do, right? And then it's like
Yep.
you want to do it in the best way possible. Which platform you're going to use, what data you're going to pull, how you're going to do the aggregations. Those are decisions you have to make, but the result feels clear, right? Like I want to be able to look at this time series as
Yep.
fast as possible over the places I want to look at them, right? And then you build it and you do it. But then, it's a split between the engineering bit and the data science, or what I'd even call the analyst side of this. And I feel like
Yeah.
the analyst side of it is so hard and
So hard.
so overlooked in how hard it is. And that's why everybody fails. Because
Yep.
actually building the tooling is pretty easy. But like solving the problem to the end is
Yep.
this is kind of like relates to our validation thing we just talked about, right?
Yeah.
But solving it to the end, you realize all the failure cases and you realize all the things you can't actually say. And then you realize the few things you can say that are maybe useful along the way. But it's a pretty, I don't know if that's unique to this domain or if it's just hard to, I'm trying to take a step back and think about that. I don't know. What do you think?
I think we might be more data constrained than a lot of other domains in some ways. Like, yes, we have a lot of pixels.
But we
But,
just
like,
need
again,
other
like-
modalities to verify.
Yeah, like, I don't know. Like, I've never worked in ads, but I just imagine that those data sets are ginormous, right? Like, they must
And it's
be.
very easy to measure success.
Yeah, yeah, and I feel like I don't know if I call it like the analyst side or it's like the scientist. Like to me, it feels a lot like it's
Sure.
like science, and basically we just don't like to show our error bars because if anyone saw our error bars, they would never buy our product.
I guess I say analyst because it's like kind of interpretation of the data and then the production of a report or a
Right, right.
set of results that somebody who upstream is looking at to be like, oh, this is the information I need.
Yeah, and I think it's overlooked how hard it is because like the incentives all drive towards success. Like it's just like if you succeed, this is like great. It's massive. It's, and we can sell it. And if you fail, then like what are we even paying you for? Right? Like why do you even but I feel like most of these things are gonna fail. It's just kind of how it shakes out. Like it's hard to do a lot of these things. It's hard to do them to the end. Like even in the irrigation versus non-irrigation example, if someone would ask me like, okay, well, how do I make money off of this directly? Like, can I reliably trade this signal? I mean, I feel like the answer is no. Like, I don't have enough confidence in this for you to risk money on it, but I'm being asked to do it, and I have to provide value somehow.
Given all our failures, how do you feel about Earth observation in the commercial market?
God, I'm pretty bearish. And I haven't seen it done well by a lot of companies. And maybe I just haven't seen enough companies. It just seems like the things people want out of what we can provide is like I think we can provide value. I just don't know if that translates directly to like financial and commercial value, or if it's monetizable in an easy way.
Yeah.
Maybe it should just be a public service. I don't know.
Yeah.
I don't know. How about you? Give us some optimism, Krishna.
Well, I'm not really in the commercial game anymore. When I was, I feel like I got pretty jaded after many years of bouncing around. Just because I feel like it was never the slam dunk. I feel like Earth observation as public service, like you said, or, the government case is very obvious as an intelligence gathering apparatus. But if we just talk about that for a second, it's, if you imagine the intelligence community, it's multimodal, right? So it's satellite imagery, signals intelligence, on the ground reports, and then 100 other things.
Yeah.
And all of that is forming a picture as to what's happening on the ground, right? And sometimes I wonder whether commercial plays should be like that too, and maybe they are when they're more specialized towards a particular vertical.
Yes.
Like cobalt metals might be a good example, where it's like they're not in the satellite imagery business, they're in the mining business.
Yeah.
And satellite imagery is a part of it. And so I just think it's when it's a particular solution or a industry, it just plays a supplementary role. I've just never seen it. Rarely seen it played more than a supplementary role, though. And now I work in news, and in news, it's very much a supplementary role. Sometimes very useful, sometimes can lead the story in terms of the data, but is rarely enough by itself to paint the full picture as to what's happening. And almost it's always better when there's other types of data supporting it. And so I just think that's why all the commercial companies fail, is when they don't have that mindset from the get-go and they think this is the thing we hang our hat on to do everything, and then it doesn't work.
Yeah, I think that makes a lot of sense. And I feel less bearish about those types of companies that have an Earth observation component to their product, but it's not the entire thing, and it's not their entire identity either.
Yeah.
And the reason why I'm less bearish on those types of companies is because they're dogfooding, right? Like they're going up against that. How many acquisitions do we need? Do we need a high-res imagery budget to supplement this? How does that factor into the price of what we're selling? And that just seems like a much more sensible way to go around, deriving value from this thing. I've seen some companies like raise a lot of money, like Zoopal. I still don't really know exactly what they do. But
what is Zoopal?
Zoopal raised, I think, over $100 million or euros, or actually maybe euros are worth more than dollars at this moment. So, or maybe they've always been worth more, but a lot of money to do, from what I can tell, is similar to maybe like a Descartes Labs. Like, we're going to use satellite imagery and everyone needs it because it's satellite imagery. Like, how else are you going to know what's going on the ground?
Transparency for the world.
It's a very jaded take as a journalist, Krishna. but yeah.